All right. Can you guys hear me okay in the back? Yeah? Okay. My name's CJ May. I go by LawnDoc on pretty much every social media and Discord and everything. I'm a senior IT security analyst at Vermeer Corporation in Pella. We're a manufacturing company. I gave a talk last month for those of you that were here, so if I look familiar, that's why. So today, I'm going to be talking about the JAWS programming language, which is, it was part of the CTF that we just covered, and it's an invisible programming language. So it's kind of a pet project of mine, just more for fun than anything, but I'll just kind of get into where I came up with the idea for JAWS. So a few years ago, I was an undergrad student at UNI, and it was my junior year, and it was toward the end of the year, and I was in the computer science student lounge working on some homework with some friends, and one of my friends had a project that he was working on where the professor had assigned them to look up an esoteric programming language, which is basically like BF, something completely incomprehensible, not resembling a normal programming language. And basically, they had to find an esoteric programming language and write a simple program in it. And so I was looking at the different funny programming languages with my friend, and we ran across one called Whitespace. And Whitespace is an esoteric programming language where they replaced all of the lexical tokens. So rather than saying like variable or function or stuff like that, they actually replaced all of those with different combinations of space, tabs, and line feeds. So all of the lexical tokens are invisible to the human eye when printed out on the screen. And so that was kind of a funny one that we were talking about. And we were reading into it a little bit more, and we were thinking about how interesting it was in the context of in being able to be used in polyglot code. So polyglot code is where you have one file, and it's a valid program in more than one programming language. And so because whitespace is only comprised of whitespace characters, and most programming languages are made, they just ignore whitespace, it's pretty easy for them to coexist in the same file. You don't even have to do too much fiddling to get that to work. And so, I was kind of thinking about that from a security perspective, and I was like, that would be a pretty good way to hide some malicious code. If you had a program that was, C code or JavaScript or HTML or something like that, and you hid a different program inside of that, it would appear to be something else, even though, you could run it to do whatever you want. So that's kind of how I came up with the initial idea for JAWS. And that was kind of my initial idea, was to kind of use it in polyglot code. So I kind of wanted to look at the implications of that, the polyglot code, and to kind of study that from a security perspective and what defenses might be able to detect something like that. So I decided to do my senior research project on that type of topic, and I pretty quickly realized that whitespace was going to be a little bit too limited to do exactly what I wanted to. So the whitespace programming language, it was made to be more of an April Fool's Day prank. It wasn't really, meant for people to actually use it to do useful things. So it actually didn't even include features to be able to write input and output to files or do any kind of network operations. So really all it could do was print out to the screen, accept input, and make your CPU hot. So I decided to remake my own version of whitespace, and I decided to call it JAWS, which JAWS is actually an acronym for just another whitespace. And it also had some other meanings like It's kind of like a threat hidden beneath the surface, and the way that it can interlock with other code in polyglot code. So obviously, I put a lot of time and effort into thinking about the name, and kind of went a little overboard, but at least I didn't make a religion out of it. So my initial goals for the JAWS project were, I wanted, first of all, to make it easily injectable into other types of files. And my initial thoughts on that were it would be easy to hide it from manual analysis because, obviously it's invisible to the human eye. And it would also kind of trick some automated static analysis, because if you've got a static analysis engine that thinks this is an HTML file, it's going to interpret it as an HTML file. It's not going to be looking for anything else. The second goal for it was I wanted to make it an interpreted language. So compiled code will, be turned into machine code when it's compiled, and that's understandable and comprehensible by static analysis, antivirus engines, when it becomes binary. So I actually wanted the instructions that are going to be the things that are actually doing something. I wanted that to be completely abstracted and hidden until the exact moment that it executes. So that's why I wanted to make it an interpreted language. It also makes it a lot easier to inject it into other types of files, and you don't have to compile it first. And then another limitation of static analysis is that you actually can't perform static analysis on code that you're... All right. To back up on that thought, so antivirus engines, they can't analyze anything that they don't understand how to analyze. So if you have a brand new programming language that this antivirus engine has never seen before, there's no way that it can understand what it's doing, because it would have to have, some form of the interpreter built into the engine to even understand what's going on with that code. So just one more reason why I wanted to make it an interpreted language. And the last goal was to make sure that it can do file operations and network I/O, just to make sure that I can do some useful things with the programming language. So next, I'm just going to jump into the JAWS language specification and just kind of show you a little bit about how the syntax works and how it can make valid programs. So this is my GitHub. You guys can go check this out. This is open source. It's at lawndoc.jaws. So in the top level directory, you've just got a short little introduction into it. If you go to the JAWS VM folder, then you get a little bit more of an explanation into the language. So like I said, just like whitespace, the only lexical tokens are space, tab, and line feed, which are non-visible characters when printed to the screen. And it uses line feed and not carriage return to make sure that there's no issues with DOS and Unix conversions. And that was originally a decision made by the people who made whitespace. So the first thing that you need to do when you're writing a JAWS program is you need to start your program with a header. And there's a reason for that. So whitespace didn't actually include headers and footers. It would just start interpretation, and then whenever the instructions ended, it would just be done. But I added headers and footers and a different end of program instruction because I wanted to make JAWS as injectable as possible. So when you think about the ways that JAWS can be injected into other files, it's pretty easy to inject it into non-whitespace controlled languages like C or HTML. You just have to replace the existing white space with JAWS, and it doesn't really matter how much or what frequency your white space is. But let's think about a language like Python. Python is white space controlled. If you goof up that indentation, it's going to be really mad at you. So how do we get around that? So I figured out that Python actually ignores arbitrary white space as long as it's in its own line. So what I needed to do was to start and stop JAWS interpretation as much as needed on their own lines, and then you could inject it in the lines, the seemingly blank lines in between Python code. And so that's why I added a header and footer. So headers start interpretation, footers stop interpretation. Anything outside of those is ignored. Anything inside of those is interpreted. And then at the end of your white space code, there's an end of program which just stops interpretation for good. So that was that. Let's get into the actual language and what makes it run. So this whole concept is copied from white space. It's the actual syntax is slightly different. I made some modifications, especially around the I/O type stuff. But for the most part, the concepts are kind of taken directly from white space. So we've got different types of operations that make. So we've got categories of operations, and then we've got the specific operations within each of those categories. So JAWS is a stack-based language. So rather than having registers that you're storing data in and manipulating from, you've got this idea of a runtime stack, and all of your data that you're manipulating, that's all happening on this stack. And then you've also got this heap out to the side, which is your more long-term volatile memory. But all the operations are happening on this stack. So you've got to have stack manipulation operations. We've got arithmetic operations. We have heap access so that we can store variables, stuff like that, for access later when we don't need them. We have flow control operations, so stuff like, jumping and stuff like that. We have I/O actions, and we have I/O control. So within each category, I'm not going to go through absolutely all of these, but just to kind of give you an idea of how it works. So first we've got, so all those categories are called instruction modification parameters, and that's the IMP. And so that's the first part of your operation. So if you start your code with space, it's going to be a stack manipulation. And within stack manipulation, we have these types of commands, which are specifying exactly which operation we're doing. So we have space is a stack manipulation. An additional space will push a number onto the stack. And you can add a parameter after the third space to push that number onto the stack. And then we have the same thing with arithmetic. You'd use space tab and then space, and that would add the top two things on the stack. And that's kind of how the language works. I'm not just going to keep shouting space and tab at you guys. We're going to keep moving on here. But that's, in general, how the syntax works and how it's actually performing these operations under the hood. Jump back here. So next I'm going to show you guys a Hello World program in JAWS. Let me, I gotta crank this up so you guys can see it. Bear with me here. What's the hotkey? Control-Shift+. Yes, thank you. Can you guys see that okay in the back? If I do LS, can you read all those? A little bit more? Yep. Good? All right. So we'll go into the first example here. So we've got our Hello World JAWS program. And if I cat it out to the screen, you can see it's clearly not visible. I actually do have a syntax highlighter for my Vim editor that highlights spaces and tabs, so you can kind of see it. It's not real fun to look at still, but this is Hello World. So let's run it. I have JAWS already installed. If you go to the repository in my GitHub, you can just clone the repository, and if you have make on your system, which is you probably should, then you can just make install, and it'll add it to your computer. So we'll run it, and it prints out Hello World. So I also have additional test files. If you were interested in looking at more JAWS code, I have additional test files in the JAWS repo. And all the test files are actually annotated. So you can add comments in JAWS pretty easily because it ignores everything except for spaces, tabs, and line feeds. So it's pretty easy to make annotations. So if I do this arithmetic here, I just added the name of the operation before each sequence of spaces and tabs. So that's all annotated. You can take a look at that if you want to. So as you can see, it's not real easy to read JAWS code. Therefore, it's not real easy to write JAWS code. And I figured that out pretty quickly. It was just not a lot of fun to try to make test programs for this. So what I ended up doing was I added a lot of complexity to my project, and I actually just made a second compiler for my project that was just it took a visible version of JAWS called Fin for obvious reasons, and it translates Fin into JAWS. And it wasn't too much effort because it was just a one-to-one, translation. It didn't have to do too much, I wasn't adding a bunch of fancy features to the language, but it makes developing JAWS code slightly more sane. And so that's also included in the repo. When you make install, it'll also install FinC. And I'll give you a demo of that here. But as you can see, the language specification is pretty much the same, but instead of spaces and tabs, we have like real words that make sense to most people. So I'll show you how Fin works real quick here. So let me scroll up a little. So we start with our header. We're going to push, we actually have to push these in reverse, the characters that we're going to print out, because what's happening is the stack is filling up like this, and as we output characters, they're going to be popping from the top down. And so you actually have to push them onto the stack in reverse. So the first thing we push is a new line character, and then we push an exclamation point, and then we just do our hello world. I did a little swagger stack dupe there instead of adding another L, and then it's just a bunch of outcs. And then you end the program with Fin. So if we wanted to compile that, we just use the FinC tool. By default, it just puts it to out.jaws, and we'll run that. Hello world. So the FinC compiler, by default, it does add annotations. If you want to suppress the annotations, you just add a S flag, and then your code is just all invisible again. So I'm going to get a little bit into the code of the actual source code of JAWS and try to explain how how I made the programming language. And I'm going to try to not get too technical because compiler development isn't the most interesting topic, but I just wanted to share some of the source code here and the general design. So I developed the JAWS compiler in C, and I used tools called Flex and Bison to generate the lexer and the parser. So the lexer is what basically recognizes all the tokens and says that's a stack imp, or that's an arithmetic imp. The lexer is kind of what identifies those, and then the parser is making sense of the order of them and kind of making sure that they're all in, that it makes a valid program. So the first thing is our lex file, or our flex file. And so the first part here, it's just kind of some C operations just to make sure that what we make is right. And then in here, this is where we actually define our characters, or our tokens. So we have different types of parameters that need to be variable. So if I wanted to add a digit to the stack, that would have to be a number. And so this is just a regular expression to make sure that we can recognize any arbitrary number. And the same thing down here. If we want to have like a network connection, we have to recognize the different octets and the port here at the end and the protocol. And so this is just to recognize an arbitrary network connection. Down here, these are our literals. So we have the, I'm in Fin. Sorry, one moment. They look pretty similar. So here, what most of the heavy lifting is actually being done in the Bison file rather than Flex, because in JAWS the only tokens are space, tab, and line feed. So we really are just focused on different combinations of those three. So now if I go to the Bison file, this is where it actually defines the formal grammar of my language. And this is kind of the part that makes JAWS kind of make sense to the interpreter and run things in the order they're supposed to. I'm not going to get too into this, but this is kind of where that all happens. So that's the recognition part. So with Flex and Bison, we're able to recognize the JAWS language, but we still don't have a runtime system. And so that was the next part, was once we recognize the language, we actually have to be able to execute the instructions now that we know what they are. So what's happening is, as the parser is reading JAWS code, it's actually recording these instructions that come in, and it's storing them in a data structure that's basically my program. So I've got a list of instructions of JAWS operations, and it's being built out as the interpreter is reading the code. And then after it interprets all the code, it will execute from beginning to end what we just built. So I'm going to get into the runtime a little bit here. One moment. So most of the runtime happens in here, and for the most part, I have a function for each individual JAWS operation, and each operation is just being executed by the C code that's in the interpreter, just on behalf of the JAWS code. So if we have an arithmetic add operation, my interpreter will read the arithmetic add, and then it'll just execute that on behalf of the JAWS code. And of course, my runtime also is keeping track of the stack that holds all the data. That's just its own data structure. And it's got the heap. That's its own data structure. And so as it's interpreting things, it's just, passing data back and forth between these data structures, doing exactly what the JAWS code says it's supposed to do. And the last part of the JAWS programming language that I tried to make at least a little bit usable was error messages, because it's not a lot of fun to debug code that you can't see. So I tried to be as specific as possible and give error messages saying it was this file. I even added it. I even have it calculated out so that it'll tell you what line of your fin file it should be on. So if you were writing your code in fin and it errors out in JAWS, it'll say it should be on this line of your fin file. So you can go back and read what that was. So the fin implementation, it was very, very similar for the most part as JAWS. The formal grammar that we looked at in the JAWS code, that was actually copied over verbatim from JAWS over to fin, but obviously fin has its own lexical tokens that are readable, not just space, tab, and line feed. So the main difference with fin was, rather than interpreting the fin instructions and then executing them, it was just interpreting the fin instructions and then writing them to a file as it interprets them. And that just becomes our JAWS one-to-one translation, and that's all that happens. So now that we've talked a little bit about how the language works, I want to talk about how to inject JAWS into different types of files. So I talked a little bit already about how to inject it into traditional programming languages that aren't white space controlled. It's pretty trivial. You just have to replace all the white space with an arbitrary amount or order of your JAWS code. White space controlled languages, typically you'd have to start and stop interpretation with the header and the footer, each on its own line. Markup languages and text files are kind of similar to traditional programming languages, where it just kind of depends on, when the white space is important. But sometimes you can actually do some tricky things to make it look like it's still normal. So if you go back, I'm going to go back and look at the CTF that I wrote that was covered earlier. If we look at the injected BF file, it actually looks somewhat structured. So I was careful when I injected JAWS into the BF file so that it would look like it's actually, somewhat structured. There doesn't look to be super random white space going on in this file. And I tried to do the same with the C code. That's not a great example. But sometimes you can be tricky about how you inject the JAWS code into the file to make it actually look like it's still, somewhat normal spacing and everything. Binary executables. So there's a few different ways you can go about this. You could just append your JAWS code to the end of the binary file. You can just use cat to concatenate it to the end. And if there's no false header interpreted in the binary file, that'll just work. I did run into this issue when I was creating the CTF, where I tried to inject JAWS into the binary. That was the original part of the Capture the Flag challenge. And there was actually a false header being read in the garbage of the binary. And so I think that I might end up making the JAWS header a little bit more complex so that doesn't happen. But I was able to get around that by just defining a static string in the source code of the binary that just contained the JAWS. Another way you can inject JAWS, you can just concatenate it to the end of image files. For those of you that don't know, you can actually just do the same thing with basically any type of file. So you can inject like a zip file into your image files, stuff like that. Zip archives, you can just concatenate JAWS to the end of that. some common questions that I got when I've been telling people about JAWS. So the first question is, won't linters ruin the code's white space and, mess up the JAWS? So that's actually kind of part of the beauty of the language is if you're doing manual analysis on this file that's doing suspicious things, and let's say you're looking at Python code and it's got all these extra lines and you're like, what the heck, I can't read this. So you go and you clean it up. Well, you just deleted the JAWS code that was doing what you were looking for. So you basically just erased the evidence. Another question that I've had was, doesn't the target computer have to have JAWS on it to run the code? So yeah, that is a limitation of the having an interpreted language is you're not compiling it for the target architecture of your target computer. You have to have the JAWS interpreter there to run it. But it would easily be made part of like an implant, like if you had a C2 implant or something like that, you could be receiving JAWS instructions over the network and just interpreting that within your implant. And the implant itself wouldn't look malicious because it's just an interpreter, which, a virtual machine, like the Java virtual machine, that's not inherently malicious, but it can do malicious things. So it kind of takes care of itself. Another one, can't you just detect the JAWS interpreter? Yes, and so for JAWS specifically, one of the things that I want to do is create, signatures for JAWS because I'm not trying to create this virtual machine that's, capable of making all this malware that's hard to find and stuff like that. But the thing is, the point of the research is not JAWS itself, but the idea of JAWS. If you can create your own interpreted programming language that can be, injected into other files or even not injected into other files, just interpreted programming language in general, that defeats a lot of static analysis tools that are out there today. And so, while you could create signatures for the JAWS interpreter, there are ways around that. I mean, you could obfuscate the interpreter, you could pack it, there's different ways to hide your payloads, stuff like that. That's not the point. The point is just the concepts in general of the way that interpreted code defeats static analysis and polyglot code. And the last question I get is, can you look for interpreters that read white space characters to narrow it down from all interpreters? I think that's kind of, maybe a good approach, but again, it just kind of comes back to you can create any language you want. It's not just, white space characters. I could swap out space tab and return for any Unicode character that's not visible, because Unicode's going to be standard on all computers. So it really just comes back to the answer to the last question, where it's more about the concepts and less about defeating JAWS itself. So the major takeaways from my project and the research that I did in college is that there are some big shortfalls in static analysis. And, it's important to have static analysis tools because they're quick wins. If you find something that's known bad and you can stop it before it can do something, great. But there's a lot of weaknesses to it. Like, you can't scan code that your AV doesn't understand. You also can't, if you have like an artificial intelligence model or something like that, you can't train that model to detect virtual machines because virtual machines aren't inherently malicious. And you can't train your model to detect arbitrary languages because you can create any programming language you want. It's infinitely variable, any sort of programming language. So there's no way to find a new programming language. So the solution that I kind of proposed from my research is to, really put a lot of emphasis on behavior analysis, because bad programs will do bad things. It doesn't matter, what programming language it's written in, whether it's comprehensible to anything outside of your JAWS interpreter or whatever you have. If your code is doing bad things, it'll make some noise and there will be detection opportunities there. So lastly, I just wanted to finish off with some future ideas that I had for the project. it would be great to add a debugger to JAWS, the virtual machine, because it is not fun to try to troubleshoot when your JAWS code is not working well. Another thing that would be cool is an LLVM backend that's targeting JAWS. So that would basically make it so that you could compile C code to JAWS rather than, Fin. Another idea was creating a JAWS injection tool that, depending on the file type, would inject JAWS code in different ways. You don't have to do that manually. And conversely, it would be awesome to have a JAWS extraction tool where you could, detect JAWS in a file, pull it out, and even maybe add annotations like the Fin compiler does that, highlights what operations are happening. I'd like to add some options to the make file so that you can suppress output of the virtual machine so that, it's running silently and not actually outputting things to the screen. Also able to suppress error messages. Another feature that would be really cool is to modify the lexical tokens with like a tool like sed, because if you could change space, tab, and line feed on the fly to anything you want, that would be kind of a cool way to just change up the language with very low overhead. And the last one would be a makefile option to modify or pack the VM for antivirus evasion. I also would like to try to compile the JAWS virtual machine to WebAssembly. So since the JAWS virtual machine is written in C, it can technically run on any architecture that C compiles to. And there is an LLVM backend for WebAssembly, so I would like to try that out and see if I could get JAWS VM to run on WebAssembly, because then that would open up a lot of attack surface, within browsers, because that's kind of an area of IT that doesn't get a lot of security attention. One idea that somebody brought up to me one time about JAWS was potentially detecting JAWS code or arbitrary code that you can't understand by analyzing the entropy of the file. I have some doubts about that, because I think that especially if it was injected into another type of file, that would really mess with the entropy and what's going on there. And I think that would be pretty difficult to detect. You'd have to be pretty crafty about how you were doing your analysis. But I think that that's potentially worth looking into as a way to detect something like JAWS. And lastly, I want to create a Yara rule for the JAWS VM just to be as transparent as I can that I'm not trying to make this for malicious reasons. This is just a fun idea I had when I was in college, and I really just wanted to see if I could make it work. So that's all I had. That was kind of a lot, but do you guys have any additional questions? The code at the end of the line, like... Yes. So the question was, can you put your JAWS code at the end of a line and it'll still interpret? So let me show you an example. I've got a good example in my JAWS repository here. This was a discussion that I was having with someone else. Oh, my internet's slowing down. Here we go. So this is a C program that I wrote that includes JAWS injected into it. So the spacing doesn't, look too wonky. But what's going on here is if I highlight this, you can see that there's JAWS code after the C code, because what's happening is JAWS is just interpreting only the white space. So it doesn't care if it's at the beginning of the line, in the middle, at the end. I actually got really crafty. These spaces that are in this print statement here, these spaces are interpreted as JAWS instructions. And in fact, they're in the middle of the instruction. So it doesn't matter if, there's a bunch of garbage between breaking up the actual instruction itself. You can spread that out as much as you want because it's only worried about the white space. Good question. So the question was, when I was making the JAWS virtual machine and writing that in C, how did I kind of know where to go and how to do that? So I actually had taken a compiler development course in college. It wasn't a virtual machine, so the runtime part past Flex and Bison, that was uncharted territory. I hadn't used Flex and Bison before, but I had created my own parser before in Python. So I was kind of familiar with, compiler development, the terminology, the steps that need to happen from that class. And then I just I used Flex and Bison to speed up the generation, because Flex and Bison really they generate the C code for you for the lexer and the parser, which makes up a bulk of the program. But once you have the lexer and the parser, you kind of are able to interpret the code, and then it's just a matter of whether you want to translate it to something else or whether you just want to run it and have a virtual machine. So the runtime environment I hadn't done before. That was kind of uncharted territory. I was in college, so I did consult with one of my professors who was a big programming languages guy. He kind of helped me out with a couple parts, especially the jump operations, because you have this idea in JAWS of different labels where you can jump around to different parts, and he suggested that I make some sort of data structure to keep track of where those jumps are. That was a big contribution of his. But yeah, so I had a little bit of experience before. There was a combination of having done a little bit of it and also some uncharted territory. All right. Thanks, guys.